This is lesson 11.1, the distance and midpoint formulas. The learning objectives are to use the distance formula and to use the midpoint formula. So we've been talking about radicals during chapter 8, and we're just skipping to chapter 11 really quick to cover these. We only have one section of chapter 11, and since it has radicals, like roots, right? A big long square root here, we might as well talk about the distance formula and cover the midpoint formula as well. Great. So the distance formula is a formula that allows me to find the distance between any 2 points in space, right? So how far apart are 2 points in space? The distance d between the 2 points x1 comma y1 and x2 comma y2 is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so what I do is I take the difference of the x values and square them, and then I add the difference between the y values and I square that, and then I take the square root of it all to find that distance. Great. So here's example 11.1. Use the distance formula to find the distance between the points 6, 4 and 2, 1. Now, what you'll do right off the bat is you will say, hey, these 2 points, well, this is the first point, and so I'll call it x1, y1. And this point, it's the second point in space. I'll call it x2, y2. So that's the naming system. For the first point, well, we got our first x value and our first y value. And then for the second point, that's our second x value and second y value. Now, you could have switched which one you called the second point and the first point. It really doesn't matter, just as long as you stay consistent, because we're about to plug these values into this formula right here. All right, so I'm going to use the distance formula. I'll say the distance between those 2 points equals the square root. And this may be the longest square root that you've ever used. And inside the square root, you're going to take the difference of the x values. That's x2 minus x1. Right, so x2 in this case is 2. And subtract x1, which is 6. And then we're going to take that and square it. Great. So I'll show you what I've done. I've taken x2, which is the value 2, and x1, which is the value 6. I've subtracted them, and I squared their difference. Great. Next, I'm going to put a plus sign. All right, so I'm adding the next piece onto it. And that next piece is the difference of the y values. So I'm taking y2 minus y1, and y2 is 1. That's its value. And y1 is 4. So I just took the difference of the y values, 1 minus 4. And then I finish it off by squaring that. Okay, so this is the distance between those 2 points in space. All right, so now that I've done that, I'm going to clean it up. All right, so this is the square root of, well, 2 minus 6, which is negative 4 squared, plus 1 minus 4, which is negative 3 squared. Please remember that when you square a negative number, it becomes positive. That's why I'm writing this now as the square root of 16 plus 9, right? Because negative 4 squared is 16, negative 3 squared is 9, and so I got that. And I'm going to now simplify even further. 16 plus 9 is 25 under a square root. Well, I got really excited just now because I realized 25 is a perfect square, right? So the square root of 25 comes out nice and clean. The answer is 5. All right, we're done with example 11.1. Okay, let's move on to example 11.2. Now, when we're talking about points in space, sometimes the x or y values are negative and sometimes they're positive, right? So in the first example, all of our values for the x and y values that we had were positive, but sometimes they're negative, all right? So let's see how that, kind of modifies things a little bit. First of all, yeah, this is my first point again, so I'll call it x1, y1. This is my second point. I'm calling it x2, comma, y2. All right, that helps me so that I remember how to plug it in to the distance formula right here. All right, so now I'm going to say that the distance is equal to a nice long square root. Okay? And inside of that square root, I'm going to take x2 minus x1. Right? X2 minus x1. So that's 7 minus negative 5. And I take that and I square it. Just so you see really clearly, I'm taking 7, I'm subtracting negative 5. So I have a double negative right here, which when you subtract a negative, that becomes a plus. We'll address that in a second. But now I have that plus sign, so I wrote that plus sign. And now I take y2 minus y1 in the formula. And y2 is 2, y1 is negative 3, so I'm taking 2 and I'm subtracting negative 3 like that. And then I square that difference. Great, so I've just used this formula. I'm just plugging things in the same way. I have the square root of x2 minus x1 squared plus y2 minus y1 squared. I see these double negatives, and so I turn them into plus signs. They become addition. All right, let's clean this up. I now have the square root of 7 plus 5, which is 12, squared, plus 2 plus 3, which is 5, squared. And 12 squared is 144, and 5 squared is 25, and that's all still under a square root. And now I'm going to combine 144 plus 25 to give me 169. And I get really excited because 169 is a perfect square. And so I realize, hey, wait, 169 is 13 squared. Therefore, the square root of 169 is 13. Came out nice and clean again. All right, let's try another. This is example 11.3. Use the distance formula to find the distance between the points 10, negative 4 and negative 1, 5. Write the answer in exact form and then find the decimal approximation. Round it to the nearest tenth if needed. All right, it looks like I've got 2 points in space. Here's the first point. Here's the second point. So just remember, hey, this is x1, y1. This is x2, y2. My first point, my second point. So using the distance formula, I get out a nice long square root. Let's try that again. Nice long square root. There it is. And inside the square root, I take the difference of the x values. Well, so I'll start with x2 minus x1. So that'll look like negative 1 minus 10. And I take that difference and I square it. And then I add it with the difference of the y squared. All right, so I'm taking y2 minus y1. So that looks like this, 5 minus negative 4. And I square that. Great, let's clean it up. I've got the square root of negative 1 minus 10. Yeah, that's negative 11 squared. Plus 5 minus negative 4, well, yeah, that becomes a plus, and so 5 plus 4 is 9. So I get a 9 squared. And now I'll do the squaring. Remember, when you square a negative number, it just becomes positive, right? Like negative 11 times negative 11, that's 121. And that's plus 9 squared, which is 81. And so cleaning this up a little bit, I get to this point, and I say, well, that's going to be 202, right, under a square root. The square root of 202. Now, this is the exact answer, right? The square root of 202 gives me that exact value. But we're asking, after finding the answer in exact form, then find the decimal approximation rounded to the nearest tenth. The nearest tenth is 1 decimal place. All right, so in your calculator, you can type the square root of 202, and you're going to get the approximation of 14.2. It's approximately 14.2. All right, here I'm going to box the exact answer, and then here is the decimal approximation. Awesome. Now that you have learned the distance formula, it's actually a very powerful tool because you're able to find the distance between any 2 points in space on an XY coordinate system. Okay, it's very powerful, and you'll end up using it a lot as you continue forward in your math courses and other courses. Now let's learn about a second formula called the midpoint formula. All right, so the question arises like, okay, let's say I have 2 points in space. How can I find the midpoint between those 2 points in space? All right, the midpoint formula helps me do that. The midpoint of the line segment whose endpoints are x1, y1 and x2, y2 is x plus 2 over 2, y1 plus y2 over 2. Let me say that again. X1 plus x2 over 2, y1 plus y2 over 2. So what are we doing? We're taking the x values of the 2 points and adding them together, and then we're dividing by 2 to find their average, right? So that'll be the midpoint of the x values. And then we're taking the y values, right? y1 and y2, we're adding them together and dividing by 2 to find the average of the y values, and that is how we find the midpoint. Here's a statement. To find the midpoint of a line segment, we find the average of the x coordinates and the average of the y coordinates of the endpoints. Cool. So let's apply this in example 11.4. Use the midpoint formula to find the midpoint of the line segments whose endpoints are -5, -4, and 7, 2. Plot the endpoints and the midpoint on a rectangular coordinate system. Great. So I'm just going to leave this formula right here so you see this as I do this, right? So my goal in finding the midpoint is to take the sum of the x values. That's -5 plus 7, and then just divide that by 2 to find their average. And then take the sum of the y values. That's -4 plus 2, and then divide by 2 to find their average. And so this is -5 plus 7, which simplifies to 2 for the numerator, right? 2 over 2. And -4 plus 2 is 2. So I get 2 over 2 again. And 2 divided by 2 is just 1. It looks like my midpoint between these 2 points is 1, 1. This is the value of the midpoint. Okay? If I was to like plot that on an XY coordinate system, I'll do that right here. I'll just create a coordinate system from scratch so you can see, hey, I've got the point -5, -4. That means I'm going 5 units to the left from the origin, and then I'm going down 4 units. Okay, so I'm plotting the point right here. That's the point -5, -4. It's there in quadrant 3. Now I'm going to plot the point 7, 2. So I'm going to go 7 units to the right. 1, 2, 3, 4, 5, 6, 7, and then 2 units up. And now that is the point 7, 2, right there. And so I have calculated the midpoint. It's the point 1, 1. Let's see if it looks like it's halfway from between the 2 points. Okay. And so I've got that point 1, 1. Does that look like it's the midpoint? Ah, I see what's wrong. I needed here to say -4 plus 2 is -2. All right, so negative 2 there. And negative 2 divided by 2 is negative 1 there. I was just missing that negative. You guys see it, right? Negative 4 plus 2 is definitely negative 2. Negative 2 over 2 is definitely negative 1. So my midpoint is 1 comma negative 1. And there it is. Okay, I'll do it in red. Cool. That's why it's so good to plot things because, I plotted 1 comma 1 and it didn't look like it was like halfway in between the 2 points. But now that I fixed it, look at that. It looks like it's the exact middle between these 2 points in space, right? This is the midpoint of these 2 endpoints. Great. So there you go. We have just used the midpoint formula to find the midpoint between 2 endpoints in space just by adding up the x values of the endpoints, dividing by 2 to find their average, adding up the y values, endpoints, and then dividing by 2 to find their average. There you go. So this has been a quick introduction to using the distance formula and using the midpoint formula. And I hope that this has been useful to you and that you have a wonderful day. I'll see you in the next lesson.